ever.
Hi, so this is gonna be show and tell for our Sidekiq effort to introduce load balancing for Sidekiq. So I have prepared small presentation. It's not fully finished, but it will help. And then we will look at some code and see how it goes. I will share my screen. Do you see my?
Yep,
Okay.
all fine.
So I prepared some slides. We will go and I will mention like some details related to the actual load balancing implementation that exists as our own solution. I will focus a little bit on sticking connections for the Rails application, not the Sidekiq. I will mention like why we didn't introduce it for a Sidekiq, and then we will discuss some specific things that were done to enable like load balancing for Sidekicks related to the data consistency workers, how sticking is working on Sidekiq compared to the regular web server, some metrics that we introduced, some future work that we like still need to do, and we will take a look at the code as well, and I will left some time for the questions. So we ended up at some point like few years ago, like building our own solutions. We tried several ones like Octopus and some others, but we in the end decided to like develop our solution. There are some like talking about utilizing some features from Rails 6.1 and maybe use something different in the future, but our solution is pretty much simple because it essentially works by replacing the active record based connection with our proxy object that will handle like routing of all queries. So the query will be like intercepted, and based on the method that is called, we will decide should we use the primary for like if the query is writing to the database, it will go always to the primary, and if it's not, if it's read only, we will try to like read from replica. If certain conditions are met, like replication log is low or less than some of the like logic that we have there, and we will use the replica. This is pretty much simple thing to do, and the good thing is that we are not parsing the actual queries. So this will allow us to just go to the next. Like we can load balance as many queries as possible, because this will allow us to, this is allowing us to like even load balance the queries that are not in our code base, because any query that is executed is intercepted by this proxy, and based on the method that is called, it will like hit the primary or the secondary, depending if it does writes or it just read only and meets the requirement that replication log is low enough and that we have all information that we need. We can go to the sticky connections. Like there is a problem that we wanted to solve, and that is the like make sure that the information in the replica is up to date, like compared to the production database. So how this works, like sticky connection, we have actually implemented a middleware, like rack middleware, that will store a pointer to the current PostgreSQL write-ahead log position at the moment when write is performed. And we will keep that write-ahead log in Redis for a short duration at the end of the actual request. So to make sure that this is not like shared among all requests. Each user is given their own key, so actions of one user will not we will not like spill this session among users, and other users will not be affected. So in the next request, we get the pointer and compare this write ahead log with all the secondaries. So we go iterate to all secondaries and compare if they're called up with the write ahead log. Once we find the secondary that's like where the write ahead log pointer exceeds our pointer in the secondary, we know that they're in sync, and we are sure that our last write is synchronized in this replica, so we can read the data. Of course, this pointer like moves in time, but at this point, we just need to make sure that our latest write is in sync with that replica. So not that all the data are in sync. And there are separate checks that are comparing if the whole replica like doesn't exceed 60 seconds of delay or certain size compared to the primary. But this check is compared periodically. So if one or more secondaries are not yet in sync, this is probably something that we can still optimize. I think that I saw that Stan did some optimization for a specific place, but I guess that similar approach can be taken to improve this logic, because at the moment, if one out of several secondaries is not in sync, we will still use primary. So maybe this can be optimized to like, if we find at least one, use that secondary and give time to other secondaries to synchronize. There is no need to like wait for all of them to be in sync, because each secondary is replicated separately. So maybe there is still space to optimize this thing and like use secondary in more places, because it will be more probable that one of the replica is still replication process has finished for that replica and it's not done for all of the rest. But this is something that we will probably maybe need to measure on production, but this falls under the future work. So I will just show you the part of the code that is dedicated to check if the actual replica is up to date. So we are providing the location in this method, like the location is the pointer of the write ahead log location on the primary. And we are executing this Postgre query that is checking against the actual write ahead a log that is written by recovery of the replica. So when the replication process is done, this write ahead log is there, and we can compare like if it's ahead or not compared to the primary write ahead log. And that's it. Like we will just return true or false for it. Now, related to the Sidekiq, like we cannot reliably use the same sticking mechanism we have for the Rails web application, because we have no way of knowing whenever a job should use a primary or not, because most of the jobs are not directly tied to the user. And actually, it was considered that most of the workers are actually doing writes. So there was no initiative to like proceed and enable load balancing for Sidekiq because of this potential problem that we cannot use the existing mechanism, and that most of the workers are still using writes, so they will use the primary either way. But during the time and like looking at metrics, we like find out that there are workers, especially when we introduce the metric that is counting like the number of executed read queries and executed write queries. Like we now can see that there are certain queries that certain workers that are only read-only, like they don't do writes, and we could benefit from like utilizing the load balancing for those workers. And while we were investigating and looking at those workers, we like concluded that we could use some kind of data consistency attribute for a worker. So we can like mark this worker and tell that specific worker that it can utilize the actual load balancing. So for jobs that are not requiring like read write and up-to-date data, we can still benefit from the load balancing. And by annotating, like marking those workers, we can make sure, and this is also good, that we can enable one by another. Like we don't need to enable load balancing for the whole, like for the all Sidekiq workers, or we can specify which worker will utilize the actual load balancing. So in order to utilize this Sidekiq read-only database replica capabilities, like every job can have a data consistency attribute, and that data consistency attributes can be always, which means this is a default for any worker, and this worker will always use primary. So by default, all workers will still use the primary if it's not configured otherwise. And even if the data consistency is not set for the worker, it will default to always. So in case that we would like to use and utilize the load balancing capabilities, we can set that worker has data consistency called sticky. And this means that this job will try to use replica as long as possible. Second. So this means still that we can have maybe a bug or something that in case their write is happening on that worker, we will fall back to the primary. Or in case that replica is not caught up to the write ahead log, we will still like fall back and use primary. So if we schedule a job and we collect the write ahead log the same way as we do for like sticking connection for the Rails application, and we compare that write ahead log against replica, and replica is not caught up, current replica on the Sidekiq server while the worker is executing is not like caught up to the write ahead log that we like sent or collected, then we will just simply fall back and use the primary. The sticky is considered to be used on the jobs that will require to be executed as fast as possible. That's why we are not trying to wait a little longer or retry this job and wait for replication process to complete. And we don't want to give replication process more time to finish because we care about this job to be executed. So if replica is not ready, we will still use primary and get a result as soon as possible. That's why we have a different data consistency called delayed, and delayed is intended to use replica always. So it will use primary exclusively only if there is write query executed in that worker by some error, bug, or something. So if the worker executes write query that will write to the database, we will then move and use primary. In all other cases, if the replication log of the job is long and replica is not up to date, the job will be like retried. We will use the Sidekiq retry mechanism and we will retry this job and give it enough time, like it will be executed, I think by default 3 seconds later, or depends on the configuration. And then we will try to execute it again, and this time we expect that replica will be actually ready. If the second time replica is not up to date, then we will switch to the primary again. So we will not retry it again. We will use only one retry in order to give replication process enough time.
Can I ask a quick question in between?
Yep, please.
Because otherwise I'll forget about it. So what I'm wondering is would it make sense to have, because all of these sound like kind of intelligent, like they're like smart, right? They try to monitor what the job is doing and then try to apply the right strategy based on a hint I give the worker, right? Because like if I say delay, it's still not guaranteed that it will always use a replica, right? Because
yes,
it might still try to detect it right. I'm just wondering why we are doing this, because like because the problem in my eyes is not that a Sidekiq worker issues a write. The problem of replication lag is if you read your own writes, that's what causes consistency problems. So but just the presence of a write can be totally meaningless, right? If I don't know, like think about the import stuff we worked on, right? A year ago or whatever. We were inserting like failure records into the database, but we would never read them back, right? So in a Sidekiq job. So so that's a write that would not temper with consistency. So I'm wondering, if you know that as the author of a job, shouldn't I have the opportunity as well to just flag this job as always use a read replica, because I've written it, so I know it to not cause any inconsistent reads, any dirty reads, basically.
Yes and no, it can be tricky. You don't want to pay that much attention as developer to the performance. We as a memory team maybe do, but most of the people really don't care, and it's tricky. And there is another problem. When you schedule a job, the job, like the client, Sidekiq client is executing the client middleware, where we want to store like the write ahead location so we can use it in the Sidekiq server. I will go to that implementation details later. But the problem is that Sidekiq client can be executed on Rails web application, or it can be executed on Sidekiq server as well as a client, because Sidekiq can schedule the worker as well. And you really don't know if current hosts, for example, you can execute read queries, and maybe you don't care about writes at all. Maybe as you mentioned, you don't care about that last write, but you still need to get the last write ahead location, at least from the replica you are using, because there is no guarantee that you will use the same replica on the Sidekiq server when the job is executing. So you still need to make sure that that's the difference compared to the web application. You still need to make sure that your replica is coded up to the replica where you schedule the job. So either way, you need to collect write ahead logs. So it's just the difference. Are you collecting it from the primary or from the replica? Because even if you didn't do any writes, there is still a chance that replica on the client is in different state than the replica on the server. So the replica on the server can still be behind the replica where you schedule the actual job.
Yeah.
So it's tricky.
Yeah, I see what you mean now. Okay, yeah, cool. Thanks, Warren.
So the point of delayed, like maybe we can discuss, like, why don't we have only delayed or only sticky and only always? But the idea is there are jobs where we like expire some caches, or we are just executing some hooks that will do some other job where we are really fine in delaying that execution. We don't care like that they will execute
yeah, exactly, because
immediately. So here we can like allow ourselves to give replication process as long as it needs to finish. Maybe at the moment the implementation will only use single retry, because we don't want to take, we are using the retry mechanism, Sidekiq retries mechanism. We didn't implement our custom solution for that. We want to rely on the retry mechanism, but for the most of the jobs, I think default is like 3 retries. So we don't want to use all of those retries waiting for replica. And if something goes wrong, that the job or worker like goes out and use all retries waiting for replica. And then if something is wrong with, for example, import, then you don't have enough retries to like complete the job. So we, for now, let only 1 retry, but this can be improved and modified in the future as well. So this is a little explanation how simple is to turn on the actual like load balancing capabilities for a worker. You just need to define like data consistency. This works only for the workers that includes application worker, because we have some mail workers that are actually not the actual Sidekiq workers, and they don't implement the application worker as well. So most of our workers implement this module. And the only thing yet that you need to set is to define the data consistency. As I said, if it's nothing defined, the default is always, and that's it. So you just need to specify data consistency delayed or sticky, and that's everything you need to do in order to enable the actual load balancing capabilities for that actual workers.
But why do we call it delayed, actually? I think that's,
well, the idea,
it sounds like it's less consistent, but I think what it's trying to say is it's more consistent. It's just like it might add a delay to the job execution, or?
Yes, we ended up by actually retrying the job, but the idea was that if replica is not ready, or we are ready to delay the worker execution in order to wait for replica to code up. So we are ready to delay the worker execution in order to replication process to complete. So we will even retry a job waiting for replica instead of just reading from the primary.
Right, but so the way to understand it is, so this is stronger. So this is the strongest consistency level, right?
Yes.
Okay.
Because sticky will just simply try to like read from replica, and if it's not ready, it will stick to the primary directly immediately. Like if the replica is not ready, stick to the primary. And
yeah, I gotta say, I find this naming very confusing, because I think it's totally
there was
way around, because
there
we
was
say
a huge discussion about naming, but we ended up in the end.
it's hard, I know. But do you see what I mean? Because you call it data consistency, and then you say data consistency always. If I just read this as a sentence, to me, that means it's always consistent. Whereas data consistency delayed means it's kind of like eventual consistency, where it might be inconsistent, and at some point it becomes consistent, but that's not at all what this means, right? It's kind of the other way around, right? Or am I?
Yeah, but I think that data consistency, I'm not sure, like when you say always, this should mean like data consistency.
Maybe
always use the primary, and the last one is more relaxed. It will wait and use replica as long as it can.
Oh, okay, so always, okay, so that's correct then. So always actually means it's always consistent, because it always goes to the primary. So it doesn't use any replica at all.
Yes.
Yeah, okay, no, that's cool. That's good. That was my bad, I misunderstood that.
I have a couple of questions related to that slide. So how the developer should make the decision from their perspective? Because like 2 questions in one. First, how do they know they should apply this attribute and not just go with no attributes and go with default? Will we have some sort of, you know, automatic danger bot which will check if the new job is created and ask to think about consistency? Or will we have some hints? And the second question is how to make the decision fast. As I am as developer, for example, I'm not familiar with replication logs and so on, but I need to put some attribute. Is there a short guideline for me, or are we going to provide that?
Yeah, that's a really good question. Just give me a second to find.
I mean, like,
Zoom
to
tab
weigh in on this, it
here.
sounds like very difficult to detect it automatically what you should be using. I think only the developer can probably decide that, or a reviewer. But I think it's a good idea, like, to maybe we could have a danger warning that says, here's just something to think about, right? So
Yeah,
you didn't add any
introduce a job.
label,
You
so maybe you
introduce a
want to
job.
add a label.
Just maybe you want some of these labels. Yeah, I also thought of that. And I noticed that, for example, when we discussed with Nicola put some more or less general guidelines. For example, if job is urgent, use this. If job is super not urgent, use this. So there are some, let's say, already some hints in job nature. Maybe we could document that to help make the decision, because it's tricky.
I'm currently writing the documentation related to that, and there are two aspects that we will follow. Like, to answer the first question, which workers should be use the load balancing capabilities? That's a tricky one. Maybe we will end up with danger bots suggesting that, but we are far from it. At the moment, we were looking at the database duration, database write count, and database primary count. You can see the metric here. And the idea is to detect the workers that spend a lot of time doing something with the database, like the queries are long. We are spending a lot of time executing those queries. That database write count is 0. So those workers are read-only, or there are a lot of queries executed in that by that worker. So, and they are hitting the actual primary database, because now we have a split with DB primary count and DB replica count. So you can see how many queries are executed on the primary. So we can easily detect the candidates that are good candidates to utilize the load balancing capabilities. So for now, we will rely on this metric, and maybe in the future we can maybe run CI job that will check that and suggest that this, because it's important, first of all, that worker is read-only. It doesn't do any writes. And the second thing is, yes, if it takes if it executes a lot of queries on the primary, it should be moved first to use replica. Or if the queries are some heavy queries that have that are spending a lot of time executing, still we can utilize this and move to use load balancing. And now related, should we use, okay, please.
We could go with more reactive approach, right? So we will just the new worker to go, for example, with all this, but we have this metrics and maybe some alerts to see if some workers are writing too much to primary, and then investigate case per case and add this attribute, right? So yeah, something like this is also
that's the idea. So we can roll it out safely, and we can keep track, because when it's not a good idea to move all those workers to the replica itself, because I'm not sure for infrastructure how it's configured at the moment. Before the replicas, the secondaries are not even configured for the Sidekiq itself. So maybe we will need to increase the number of replica, and we don't know the full impact if we enable it for a lot of workers, because we are still querying the replication log. So maybe it will increase even the pressure on the primary in the end, even if it will execute on the replica, maybe. So I think that we will need to do it incrementally and keep monitoring the replica and the primary worker by worker, at least at the beginning, until we know for sure all the aspects that will impact the performance.
So does it also mean this your feature will result in building some dashboards or some stuff in alerting related to this whole new stuff?
I would expect that. I already prepared a few personal dashboards that I'm currently looking at, but I would guess that we
Okay.
will need something like that. And yeah, it can provide really interesting data. So I believe that we will benefit from it to understand how it like affects everything.
Sorry, I have a question about the table here, or the metrics, I guess. So we have DB write count and we have DB primary count. So the DB primary count, that includes both reads and writes, correct?
Yes.
So this is basically saying this job did not write at all. It only issued reads, but they all went to the primary. Is that how I read it?
Yes.
Okay. So, and why? Actually, I'm like kind of surprised because the build queue worker, I thought it updates the build queue. Does it not issue, right? Or does it go to a different data store?
I really don't know what it does.
So but this is
yes,
not one.
It definitely
already...
does not write anything.
Okay. Okay, so these are not necessarily workers we have already classified using the data consistency. These are just workers that already existed and they do whatever.
Those are potential candidates that we can update. You can see, for example, there is a build hooks worker that we already enabled. But this is the data from last 7 days, so it's still there.
Got it.
And I really don't know what each of them are doing, but we can like guess, like it's not 100%, it needs to be investigated. It doesn't mean that if it didn't like write anything at that time, so that's why we are looking at 7 days. So if it didn't write anything for 7 days, it's pretty much straightforward that it's probably just the read-only worker. And we will aim at the beginning, at least, at those workers that we are 100% sure, like those, as I said, workers that are clearing the cache, or maybe are just hooks that will like submit something, and that's it. So to go back to the enabling the data consistency, we support the feature flag property that you can just like define the specific feature flag for that worker, and that's everything you need to do. When feature flag is disabled, job will default to always, and it will behave like the data consistency is always, or load balancing capabilities are disabled. And when you enable it, it will behave as expected. It depends if you set data consistency to sticky or delayed. And that's pretty much it related to enabling load balancing capabilities for Sidekiq worker. That's all. Most of the remaining work is about like utilizing this capability for different workers that we already detected that are good candidates and read-only workers.
I have a question. How we could prevent updating the job which has this attribute, but some developer will decide to add some write to it? Because they updating job.
I understand.
How to
as I said, there can be a bug, and that the job will eventually like do some writes, and delayed is only trying as long as possible to read from the replica. If write is performed, there is still that connection proxy that if it executes write, it will fall back to the primary automatically. So this will not, like setting data consistency to delayed will not forbid this worker, prevent this worker to write that to the primary. So if the worker does some write, it will fall back to the primary immediately and do the write on the primary database. If someone implements something in that worker that will do actually write to the database, it will still use the primary, and we will see it in the logs that it still hits the primary.
Maybe I miss a bit something, but at this point, it almost seems like the system is clever enough to figure out on itself, like almost.
Well,
Because
as
like
I said, the good feature related to implementing this proxy that will just like intercept all queries is that we don't parse the actual SQL. We are just like using the methods. So if it executes anything that writes to the database, it will stick to the primary by itself. The only problem for the Sidekiq was to handle the replication lag, because it's tricky, because you don't know when the job is scheduled. Do you care about writes that it does? And since it's executed later, you're not sure if the replica that it will hit is like up to date to your desired write, and it's difficult to decide what writes are important. And even if it doesn't write when it's scheduled, it still can happen that replica is not synchronized with another replica when the job is executed. So this is the trickier part, but related to writes, this is implemented already in the load balancing thing, and it will happen automatically. So even if we change data consistency to every value, it will still always go back and use
one more question, maybe weird one. What if you put all workers to the biggest level, I mean to delay, to act, to stick to replica as much as possible, I mean to go to replica? What in worst case could happen? Could we get some bugs, or will we just hit replicas too much? And what's the downside to go with the most replica first strategy always, and then fall back? Will it just add delay? So sometimes we know that we should always go to primary and that we could go, otherwise we would make the jumps.
The main problem is that you need to check and compare if a replica is up to date every time. So it can give you additional pressure on the database if you just enable it for every worker error, even if you don't need, because you will have additional work where you will write, you will get the write ahead log, you will need to query it, and then you will need to run another query when the worker is executed to compare if this replica is up to date. And then when job is executed, actually, it can still write, and then it will use primary either way. So you're executed 2 queries more without any need. And as I said, while scheduling, you can schedule a lot of job in single request, which will also query for if each scheduled job, the database for write ahead log, which is not, maybe it's cheap operation, but still it's querying the database. So it's not that cheap. So that's the reason why it's safer to always write to the primary without any additional queries.
But just to clarify, if everything will be too delayed and we don't put the pressure as an argument, will we expect that the system will be operating right if it will survive the pressure?
We do,
just
but
curious.
it can also impact on Sidekiq queue, because you're actually not delaying but retrying a job. So you're putting the job again in the queue. So it can happen that if most of the jobs are retried because replica is not ready for some reason, or we cannot cope with replication, maybe the queue will pile up as well. And
okay, thanks.
Okay, let's move. I will try now to explain what we did in order to allow this data consistency, what is the actual implementation logic behind these sticking connections for Sidekiq, actually, how we achieve that. And basically, it goes like this. If the Sidekiq job has data consistency configured, to any value different than always, if we set sticky or delayed, the moment when the job is scheduled, we need to keep the current primary write ahead log position if the write was performed. So if we detect that write was performed is this request, so this can happen like when the job is scheduled in controller somewhere. If any write what has happened in that request, we will write the write ahead location to for the primary database. And yes, even if we don't care about that actual write, because we cannot be sure what the worker will actually be doing, because this is the middleware work and we are not sure for which worker do we care or we do not care for that particular worker, because this is the logic in the middleware. So we are not aware what is the actual worker there. So we will just in case always keep the current primary write ahead log if we detect that write was performed. If the write was not performed, as I already explained, it can still happen that the Sidekiq client replica is different than the Sidekiq server replica, because when we schedule a job, we can schedule on Rails application like process, and it can use replica because it didn't do any writes, but we have no guarantees that that replica is the same replica where the Sidekiq job is actually executed on Sidekiq server. So Sidekiq server can connect to different replica, and those two replica can have different replication log compared to each other, because we are not like synchronizing them together. They have, each of them have its own replication process happening in the background. So in that case, we will, if there is no write, we will still keep the write ahead log for the replica. So we will query the actual current replica and get the write ahead log location for that replica instead of write ahead log position for the primary. Yep. So when the job is actually executed by Sidekiq server, so the client will put it just like, it will push it to the Redis queue, and when it's picked from the queue and executed on the Sidekiq server, the job will actually contain the database write location, either replica or the primary that we already provided, and that location is pointing to the write ahead location, as I said. So we will compare this location to the current replica, and if the current replica has this write ahead log pointer that exceeds the provided location, we will know that they are in sync and we can safely use this replica for our read-only queries.
What does this pointer look like? Is that a timestamp or?
It's a string.
It's a string. Okay. So it's like a Postgres internal concept,
yeah,
or?
Yeah,
okay.
It's something hash like 00 / some hash. Or some number / hash, something like that. So it's a Postgres thing. I'm not that much familiar how it actually works. So if the current replica is not caught up, as we already explained, data consistency is set to, if the data consistency is set to delayed, we will retry this Sidekiq job using the default retry mechanism by Sidekiq. We will raise exception and the job will retry, and that's it. And if replica is not caught up the second time this job is executed, we will fall back and use primary. If the data consistency is set to sticky, we will not retry a job. We will immediately fall back and use the primary. And
so do we fail the job fast? Like, do we throw an exception or something to forcefully fail the job if the pointers do not, if we detect there's lag, so that it gets retried, or how does that work?
Yeah, if we are using data consistency delayed, we will just raise an exception. The job will not be executed at all, and default Sidekiq retry mechanism will catch this exception and retry a job. So
okay, so we do that. Okay, that makes sense. So we do that before we even start that.
So the actual implementation details, we have this Sidekiq middleware where we put all the Sidekiq middlewares in the chain.
Yep.
So we have the server configurator and client configurator. For both client and server configurator, we added two different middlewares. One is Sidekiq client middleware, and the second one is, of course, Sidekiq server middleware, like load balancing Sidekiq server middleware. In Sidekiq client middleware, we will, like, before the work is actually scheduled, we will try and mark the actual database write location and fill the job with that information. So when it's picked up from the queue, it will contain the actual information about write location log. So in case when the worker is not set to always, like it's when data consistency is not set to always, and if future flag is like disabled, we will read primary write location in case that in this request we performed any writes. Otherwise, we will just read database replica location. And additional logic here is we will not do this again if the location is already provided, because if you delay a job, for example, calling perform in instead of perform async, this will execute this middleware twice, once on Rails application and second time when the delay time pass on the Sidekiq server side, when the job is actually be put on the queue when the time has passed. So we don't want to override this write location again, or when the job is retried, we don't want to set this write location again. We will use only location when the actual job was scheduled for the first time.
And this performed write method, does that, what is the scope of this? Like, does it include the original request that I might have sent as a user that triggered
so
the Sidekiq job?
This session, as mentioned in the beginning of the slides, is using request storage. So we will detect any write on the request level, and we will set this flag that write was performed on the request level. So this session will last as long as request.
Okay,
lives.
that sounds like, wouldn't it be like super probable that there will be some kind of random write when I send a request? It might be something benign, you know, like a counter being, you know, like an eyeballs table or something, where like a counter is incremented that has nothing to do with the data I'm fetching or the job I'm triggering, though, right? I'm kind of surprised to see that, because I thought the scope was the job, right? So as soon as the job starts to write.
This is the already existing logic that we already use on the Rails application as well. This is how we check if the writes were performed. And there is also some of the logic, I don't remember the actual implementation details, that are guarding such queries to be counted against it. So
okay, so we do it the other way around, basically. So we kind of cast a really wide net, and then we flag certain things as do not count into that. That's interesting.
Yes, something like that. Yes, and this is only your request, so
yeah, sure. But I mean, you know, like how many queries and requests typically?
Yeah,
the average request, how many queries?
Some specific things. Yeah. It will count everything in that request. And this is executed, as I said, when the worker is scheduled, and where the execution logic looks like this. We will check if the worker execution requires primary, and this will actually check the data consistency settings. If it's always, then it will require primary always. If the future flag is disabled, it will require to use primary always. If location is not provided, it will require to use primary. And then we will check if the replica is up to date. It will execute the actual query I showed you in the beginning. So it will compare the location we provided against the actual replica, but this time it will check only for the current replica. So there are some future work that we can improve this, but the point was we didn't want, like, the logic in web application will just go around and check every replica, is it up to date? But we just want to check this one. But since we are checking only the single one, the current one, and the current one is picked randomly, the logic that is picking the current hosts will just use a list of hosts and call next, and before that it will just shuffle that list. So it will be really picked up like out of the replica list randomly. It can happen that we will pick the replica that is not up to date, and it can happen that there is a replica that is actually up to date. So maybe there is a balance, like we didn't want to query all the replicas because that can be expensive. But on the other way around, for the web application, we are querying all of them and fail even if some of them are up to date. So maybe the middle ground would be to, I don't know, check and keep a list of online replica and maybe check, I don't know, search for first that is up to date or something like that. So this is something that can be discussed and maybe even improved. It's really just finding a right balance. Like if we query only one replica, then it can happen that we fail and the replica is not up to date, but there is an existing replica that is currently up to date. But if we start and query each of them, that can be maybe expensive to run on every worker execution. So it should be some kind of middle ground. Maybe the middle ground is, if this host is not caught up, check the next one. So I don't know, if you find the first one that is up to date, in the worst case scenario, you will check all of them, but maybe at least try one next. I'm not sure. Like I'm just talking out of my head because maybe.
Sorry, quick question about, I'm still trying to piece it all together. So location, is that this well pointer here?
Yes. Yes.
Okay. All right.
So it will just query the provided location against the actual replica right ahead location.
So it's kind of like the position in the log, like where it's currently. Okay.
Yeah. Yeah. I can send you a link or maybe put it here. So it's actually.
Yeah, I think I'm. Yeah, there you go. Yeah, I was looking at the code and at the query where it's calling that function. Yeah. Oh yeah, cool. That's really interesting.
So I'm not sure if anything. Yes. So if replica is called up, we will choose replica, and actually we will not tell the session to use primary connection. And if data consistency is delayed, we will just raise exception on the first try, and that will stop this worker from executing and put it back on the queue, and it will be executed again after some time. And in case that it's sticky, it will just fall back and use the primary. And that's pretty much all the logic behind it. We just introduced two middlewares. That's
one more question. How many retries do we have in our workers? Do you know that? Because I mean, do we wasting, for example, when we do this delayed, do we wasting one retry from the whole retry pool, or do we not count it since it's kind of technical retry and not logical retry? I just wonder, because do we mix like retries because something went wrong in the code and retries because our replica stuff is not caught up? Is it the same pool of retries?
It's the same pool for retries because we use the default mechanism, and default mechanism is a little bit closed, so you cannot modify the job hash inside your middleware anymore because it's duplicated by the Sidekiq implementation, etc., etc. So you cannot like change anything. So we are currently using the same pool, and yeah, it will take, if we retry because replica is not ready, it will reduce the number of retries if something goes wrong in the future. So this means that that's why we will just retry once, not
Okay,
more
stupid
times.
question. Do we need that we should adjust? For example, if developer wrote a job and he thinks that it shouldn't retry, so if something went wrong, then it went wrong. Should we adjust it to include retries now, all these jobs, because it could fail because of data consistency, or am I overthinking this? Or should we, increment all retries count by 1 now?
There is an open issue about improving this retry mechanism, where I provided the new retry mechanism that will use some Sidekiq implementation details, but I think that conversation and discussion ended up by just putting a warning. Because at the moment, if you set the database, the data consistency to delay to the worker that has retries disabled, it will not retry a job. So the job will just simply fail, which is not desired behavior. So we will at least add a warning about it, and maybe raise an exception if like you cannot have retries disabled and use the data consistency, or we can go with the more complex solution next iteration and have separate mechanism that will not count against Sidekiq regular retries. But this can be tricky because if Sidekiq changed the implementation and we are relying on Sidekiq implementation details, and we don't want actually to have that. And I think that in that discussion, it was mentioned that I think default of most of the workers is 15 something retries. And for others is still at least 3. So that we are fine if we are taking only 1 if replica is ready. But this is something that can be tweaked in the future if it shows that it's inefficient or needs to be improved. So
okay, thanks.
Let me go back to the slides. These are some of the metrics that can go to the future dashboard or monitoring thing. This one I show you you guys this morning. This is just a metric that shows database replica count. So all queries that are executed against the actual replica. And here we can see the whole history once we enabled the load balancing for Sidekiq and all the workers that are actually utilizing this and hitting the replica. And you can see this green one is currently problematic because it's not supposed to hit the replicas. So I'm currently investigating if we have some kind of race conditioning or like the Sidekiq session is like leaking somewhere. So this metric gives us really good input of what's going on and when something was enabled and how it's behaving. This one, for example, was really like showing what's going on when we had this rollout of build hooks worker. We could show, this is just showing like how many times database replica count was hit by this specific worker against like the primary database. And we can see, since we had the percentage or incremental rollout, how the primary database hit was reduced in steps, and in the same time the database replica count was increasing. This is this blue area. So in the end we had number of primary counts hit the 0 and replaced by hits to the replica, which represents the blue area. And this one is also interesting. It shows the actual number of operation per second on the primary, on the replica, and total number of operations. And you can see the orange line is the primary, like number of operation per second on the primary, and the blue one is number of operations for the secondary. And you can see this is the timeline of our incremental rollout, where we can see that the blue line started appearing, at least very little, and then it completely replaced the number of operations on the primary. So the blue line replaced the actual orange one, and it fits completely with the total number of operations in the end when incremental rollout was done. So this graph gives us really good overview of how the rollout was going and was it working or not. This one is also interesting. This is a metric where we count the actual decision. Did we choose to use primary? Did we choose to use replica? And did we choose to retry a job? And the yellow line here represents build hooks worker where we choose to use replica. There are no, the blue line shows 0. We didn't choose ever to use primary. And you can choose, you can see interesting thing. It's when we decided to use retry a job because replica was not ready. So the green line is shown in 2 different timelines, and we actually did retry this rollout for 3 times, and 3rd time it was successful. 2 times we reverted back. First time we reverted because our infrastructure configuration was blocking some ports, so the firewall was blocking ports and we couldn't connect to the replica. This can be seen here as well. You can see this jump, this green jump here in number of replica count. This is when we finally fixed this and enable those ports so we could connect to the replicas. And this happened to this first time. On the second time, we had this problem fixed and we enabled the build hooks worker, but you can see the green line here is showing the number of retries, and we saw a huge number, almost more than 50% of build hooks worker were retried. And this also showed as increased number of failed jobs, because when we retry a job, we log it as a failed one, even if we retried later. So we detected that there are a lot of retried build hooks worker jobs. And then we figured out that this implementation is good, but there is a problem, because it can happen for some workers that execution time, like the time when you schedule a job and when the job is executed, the actual time between those 2 is really fast. It can go to 3 milliseconds or something like that, 0.003 seconds. So it's really fast, and it doesn't give enough time for replication process to complete. So in case you don't hit the same replica again, it can happen that the replication process is not in sync, especially on production where there are a lot of writes happening. So it can happen really often that replica in that case is not ready, and then you just retry a job. After that, the job will work fine, but you just used one retried and you already reported the job has failed, which was not desired. So we ended up adding additional delay. So if you use this particular build hooks worker, it will delay the scheduling. When you call perform async, it will delay the job scheduled for 3 seconds from the moment you schedule it. So you make sure that it will have enough time that replication process will complete. And as you can see, once this was deployed on production, from the right side of the graph, there are no more retries for this build hooks worker. So when we put the delay, we can see that this job was almost never, actually, it was never retrying again. So replication process completed in 100%. And that's leads us to the future work. One of the things that are important, as I mentioned, we detected that there is at least actually two workers that are currently hitting the replica and they're not supposed to. They're connected to the build hook worker, but we can see on the graph that I showed first that this was happening from the moment Sidekiq load balancing was enabled, even while build hooks worker was not rolled out to utilize these features. So it seems that it's probable that there is some kind of, I don't know, race conditioning, or that session is spilling somewhere because maybe we just cleared the request session at some stupid place, and this can lead to the problem. So in order to continue working on this and enable load balancing for the other workers that are good candidates, I think it's important to make sure that we are not like having those unexpected workers hitting the replica, because it can be dangerous, because replica can be stale and doesn't it doesn't contain the information that we are maybe needing. So like stale reads can be problematic. So we would like to prevent that and make sure that by enabling more workers will not cause more other workers hitting replicas. And yeah, we need to fix this. And another thing is to utilize this feature that we implemented for delaying the build hook workers to all other workers, because we know at the moment that replication process needs at maximum 1 second. So I think that by looking at metrics, we can determine the like optimal number, the soft spot, and if data consistency is set for such workers, that we can like delay automatically the execution of that worker from starting from 200 milliseconds to probably 1 second. There is still like ongoing discussion or dilemma. Should we have different values for sticky data consistency and delayed data consistency? Because for sticky, we care that it's executed as fast as possible. So maybe we are fine if in probability of 80% of workers are hitting the replica and 20% will fall back to the primary. Maybe. The biggest problem is determining this soft spot. I'm not sure like how to do it, because it's tricky to leave to the developer to decide what is the delay time for specific worker, especially because it's not related to the actual worker, but to the replication like process duration. And the only thing that developers should decide is, do we care about this worker to be executed immediately, or we just can wait 1 second, 3 seconds, 10 seconds in order to this job to be executed? Because for jobs that are like clearing the cache or just firing some hooks, we really don't care if it's executed immediately or a few seconds later. And it's important to say that Sidekiq is not guaranteeing the execution as well. It just guarantees that it will be put on the queue immediately. Depending on the size of the queue, worker can be executed even a few seconds later. So it doesn't make any big difference, but it will help to provide automatic stability and prevent unnecessary retries of such jobs, at least. So when we finish those two things and update the documentation, as you saw, enabling it for the specific workers should be really straightforward. It's really simple thing to do. We just need to like keep an eye on those metrics and roll it out. It's really one-liner to be enabled for specific work. And there are also some other issues related to improving, for example, the retry mechanism. And there is also potential when we introduce new workers, like enable this load balancing thing to other workers, maybe those queries that are getting the actual write-ahead log location can be expensive, because I know that we are bulk scheduling some workers, like there are a lot of workers scheduled in one request. And if we query for each of those scheduled workers the write-ahead log location, maybe this will create a pressure on the primary without reason. So maybe we will need some improvement and add some kind of caching on the host level or on the request level for getting that location, because the location will be the same for the same request for sure. For the primary database, there is no need to like query it each time, but this is something that is currently not done and can be improved. And there are other mentioned, like, do we need to compare only one host? Should we compare more of them? If, I don't know, we compare all of them, should all of them be like synchronized, or maybe we are fine with just finding the first one that is up to date and choose that one? So there are still a lot of work where we can make additional improvements, but first and most important is to fix these current issues and roll it out to a lot of workers so we can measure the actual impact and reduce the pressure on the primary database. And then later in next iteration, maybe we can implement those additional improvements as well. Any questions?
That was great. That was really, really great. Thank you, Nicola.
Yep, I agree.
I don't think I have any more questions now. I will probably have more when I dig into it myself. I have to work on something, but that was super useful as like a, yeah, it's more than just a big picture overview. Also, like talk a bit about the internals. That was interesting.
Thank you. Okay, if there are no questions, then I will just stop recording.